Hello everyone, and thank you very much for joining me in this tutorial. In this video we are going to check out this license plate detector, with the help of which you can detect the number plates of each of the car coming in the video, and also you can save the number of each plate in the database. Okay, how this application works and what all things have been done in the backend to create this amazingly beautiful application, that is what we are going to see in this video. So stay tuned with me. Let's come here and simply upload a file first. So I'm going to go with this video named file, and let me just come here in this static folder. So right now we have a couple of files here. Let me delete all these files. What happens is, the moment I'll do this process video, the file which I've uploaded will come here. As you can see, it has come here now, and the output video is now getting prepared. See, so each and every frame is getting processed, and the code is checking the number plate in each and every frame. Then based on the processing, it is also saving the number plate number, or the number which it gets to detect in the database. We have kept in mind that duplicacy doesn't occur. So if suppose it detects the same number more than one time, it will be saved only once in the database, not twice or thrice. Okay, so by the time this is getting processed, let me just tell you what all things are making this number detection thing possible. So here we have utilized this YOLO V8 model called best.pt. Okay, how we have created this model, that is something which is really important to understand, and that is something which I will be focusing on more on this video. So what you have to do is, you have to come here in this roboflow.com. okay, this is a website wherein you can come and create your own account. Once you're done with creating your account, you have to simply type number plate detection RoboFlow. Okay, so what it will do, it will give you this link here, and this link will take you to this data set. Fine, wherein you can see we have all around 10,000 something images. So now you have to fork this data set. The moment you will do this fork data set, you will see the data set, complete data set in your panel. So this is my panel, which is with name, this is my workspace in RoboFlow with name Shrish Radha. And here you can see I have this data set, okay, which I forked just before this video. And after you're done with getting this complete data set in your workspace, you have to come here in this where is that, versions, and then here you will have to see, you will not see this download data set in the beginning. Okay, for getting this option, you will have to first train the data set. Okay, you will have to first do some analysis on this data set. How that analysis happens, let me just show that to you. So I'm going to simply put here tennis ball detection. Okay, and it will take me to some random data set having tennis balls. So this is the one. Let's take this one. Now let me fork this. Do we have the fork option here? We do have fork data set option. So I'm done with forking the data set. Now it will open in my workspace automatically. So I don't have to go anywhere. See, so this is what you will get in the beginning. Initially, this is what you are going to get once you're done with forking the data set. After that, you have to come on this pre-processing, and here you have to add the pre-processing steps. So you can go with auto-orient, right? You can go with resize. So if you know about image processing, you must be knowing about all these terms also. But if not, then randomly you can pick up 3 to 4. Then you can continue, and here you can add the augmentation step. So even if the image is flipped, which you're passing as an input, the detection should happen. That's what it means. Same goes with cropping. Okay, you can read out the content also here. Grayscale, so the image can be grayscale also, which can be passed as an input. Now once you're done with adding all these things which you require, you can continue, and then you can simply select the number of images you would like to train your model with. Fine. Now here if you see, we have require upgrade. So if you have an upgraded RoboFlow version, if you're using an upgraded RoboFlow version, definitely the code that you will get, the YOLO V8 code that you will get, will detect for you everything accurately. But because I'm using an non-upgrade version, that is the reason the model which I may get from this complete process may not give me the accurate result. Okay, so just keep that in mind, and once you're done with it, you can simply go ahead and hit the create button. Now the processing will happen, and what it will do, it will show you this download dataset option. Now the moment you get it, just hit this option and use this show download code, uncomment this or untick this tick box. From here you need to select YOLO V8 and then you need to continue, and once you're done with that, you will get a code like this. Okay, this is what you require for generating the model through Jupyter Notebook. Now what exactly you have to do in the Jupyter Notebook is, you have to run this command here. I have written all the steps over here. Let me just show the steps also to you. So there is a Word file that you will get along with the complete code, in which you will find the steps that you can follow for creating the model through Jupyter Notebook with the help of this code that you will get from RoboFlow. Okay, so this is what you have to run first. Then this is the second command. This is the third step. And finally comes the fourth step, with the help of which you can detect the exact model location, and then using this code you can download the dataset download the model on your local. Let me show it to you in the Jupyter Notebook itself. So this is the first command which I fired, and that's what happened. This is the second command which I fired, and that's what I got as a result. This is the third command, and here if you see, I am passing epochs is equal to 30. So this is going to take really long. It may take 4 hours, it may take 5 hours, depending on the number of images you have selected. Okay, so if you see here, finally after running the third step, I ran this fourth step. Just a second, where is that? Okay, this is the one. Fine, this is the path of my model best.pt, and after that I simply downloaded it from Jupyter Notebook and placed it over here. Okay, this is the one. Then I've copied it and put it here inside my Flask application. So the one which I used for just testing the videos and testing the output and analyzing the output, same thing I've used in the Flask application also. I think my code has got completely processed. Okay, let me come on the browser and check out the output. So this is what I am getting as the final output. The process video has come here. Now let me just enlarge it and play it. So if you see, the numbers are coming, right? See, the number has come here. Okay, it may be not accurate, it may be not exactly the same what we have on the number plate of the car, but yes, you will find it accurate. Not that accurate, not 90% accurate, but 60 to 70% accuracy it will show, because the number of images which I have used for training the model are a bit low. Okay, if you're using an upgraded model, if you're using an upgraded version of RoboFlow, definitely the model that you'll get will give you an accurate result. Okay, now the numbers of these number plates have got saved in the database. This is the one where I'm saving the numbers. Let me just open this database and show it to you. open database, and I need to come here in the desktop, AI. So this is a table in which the numbers have got saved, see, right? And out of these numbers, there should be some number which should be accurate. KA02MM9091 909, KA02MM909, okay, KA02MH7256 7256, okay, 7256 7256 it is showing, but these numbers are not accurate. Fine. Okay, but this is how you can use the model for detecting the number plates. Let me now come back here on this app1.py. So let me come out of this Flask application first. Okay, and now before I come on these two files, let me just run the output file also. So this is the file which I passed as an input. Okay, and this is the one which we got as a final output. So here you will see the numbers getting detected. Okay, see, the number has got detected. Okay, now let's come here. What is there in this app.py? Let me just run this code for you, and then I'm going to show you the output. So, and here I'm going to name it as shoot video detection. Fine. So this is my app.py which I will run, and I'm closing the Flask application for now. And here I'm going to pass this video 4 as an input. Python app so see, the video has started getting created. By the time the video is getting created, let me come here in this folder and show you the videos that I have over here. And don't worry about these videos and this complete content which I'm showing you in this video. Everything will be provided to you in the form of a GitHub link in the description section below. So okay, don't worry about it. You can use it, you can set it up on your local, and then you can also enjoy this application. Now this, which one have I passed as a input? Video 4. This is the one. And let me just come here on this output number plate detection. So this is the output which I got initially. Okay, so basically what this code in this app.py over here is doing, it is detecting the number plate. Okay, but it is not writing down the number of that number plate on this video. Fine. And what is this app1.py doing? It is not only detecting the number plate, but also it is writing the number of each plate which it is detecting on the, in place of the license plate, the number of the number plate is coming. Let me show this one to you. I think in this one you will be able to see it. Yeah. So here if you see, the numbers are coming, right? So how these numbers are coming? They are coming from this code, app1.py. So when you will compare the code here in this app.py with this app1.py, you will surely find a difference. App1.py is writing down the number like this, and app.py is just detecting the number plate and giving us the output video wherein we are seeing license plate like this. Okay, here we don't have this. I think, yeah, correct. So here we have this license plate code, and here we have the number of the number plate. Fine. So that's the complete thing which I wanted to show you in this video. Let this video get processed, and after that I'm going to show you the final output which has come here. So shoot video underscore detection is the one which is getting prepared right now. Okay, so it has got prepared, and let me just open it and show it to you once. So see, license plate, correct? So if you have to simply detect the license plate, this is the code. Now if you want the numbers also to get detected, so for that you can use app1.py. Let me just let me just execute this also for you, and then we are going to check out the output, final output, video 4, and we will be seeing the final output with this name, shoot underscore video underscore detection 2. Okay, so don't get confused. Let me put the video on pause, and after that I'll come back again and show you the final output. So the video has got processed finally, and let me just come here and show it to you. So this is shoot video detection 2. So you must be seeing the difference between the earlier video and this one. So here the numbers are getting detected, and the previous one, the license plate was coming as a text for each and every number plate. Okay, so that's the basic difference. I hope you guys enjoyed this video. Do share it in your groups, with your friends who want to learn detection and things related to this. Okay, and feel free to post more ideas in the comment section below so that I can make videos on those ideas also. Right. Thank you very much for being with me in this video. Bye bye. Take care and have a great day ahead, guys.